Hey everybody, this is Mr. Lowry coming at you with another fantastically amazing math video. I don't know if you guys are getting tired of doing school via video, but man, I'm sure getting tired of doing videos, but that's okay. We will persevere and I will do everything I can to help you guys succeed. This is the homework assignment for 10.3. And I'm going to do a few of these with you. I think I'm going to do 5 of these with you. Right now here I have at the top of my page the key concepts written down. These are the things that you're going to need to be able to do the problems, okay? The first thing that is really important is the difference between a combination and a permutation. And the main difference is order, okay? In a combination, the order doesn't matter. You're not distinguishing between if you have the same group of 3 people, you don't care what order that they get picked in. That's in a combination. In a permutation, that order does matter. And so some of the examples we use is like for combination, if you're picking like a committee or a team, it doesn't matter if you have this, like however you choose those, let's say 5 people for a committee, it doesn't matter what order you choose them in. As long as that committee has those same 5 people, it's the same committee. You only count it once. In a permutation though, you might have something where you have different roles for each person, or the order that you want is specific for some reason. So if that's the case, like if you're picking a president, a vice president, a secretary, a treasurer, and a representative or something, that's still 5 people that you need to pick, but each role is going to be different, and so you can take those 5 people that you picked and rearrange them in a different way, and that counts as a different scenario because you actually have specific roles. Or, again, the order being important. So the main difference here between combination and permutation is order. Does order matter? If it doesn't matter, then you're talking about combinations. You're going to have less arrangements. If order does matter, you're going to have a lot more arrangements. The other thing that we need to know is this formula here, the combination formula. So this is a combination when you're choosing from n objects and you want to take them r at a time. And that can also be written like this, n, a c, and an r. Okay, so I'm going to darken this up for you. It's n factorial over r factorial. And then in parentheses here we have n minus r factorial. Okay. What I wanted to point out to you, and I did this in some of the other videos, is that part of this formula is permutations. So notice the n factorial over n minus r factorial part. That's kind of hard to see on the pencil on the white paper here. But this piece of it that I boxed is the permutation formula that we used before. The difference is we have this extra little piece right here, this r factorial, and what that does is it divides out the duplicates you get. So you take permutations, and then that's too big of a number. You take that number, you divide it by the number of ways you can rearrange the people that you pick or the objects that you pick, so get rid of those duplicates. So that's what that r factorial does. If you remember the permutation formula, just slap another r factorial down at the bottom and you got your combination formula. We're also going to be talking a little bit about probability. So this goes back to 10.1. The theoretical probability of an event happening is a ratio of the number of outcomes where A occurs, or the number of ways you can get A to happen, whatever event you're talking about, divided by the total number of outcomes in the sample space. So it's the number of ways to get what you want or what you're looking for divided by the total possible ways for something to happen. And then we're going to use that in a second. So your first 2 problems are 6 and 7, and these are just actually, they kind of refer to example problems 3 and 4. So I wanted to run through those with you. If you want to go back in your book and look at example problems 3 and 4, you can do that. And they're just on page 645 and 646. But I wanted to kind of give you another example for you. So number 6 says, how many different ways are there? Let's see, I'm going to pull the book here for you. Okay, this is number 6. How many different ways are there to purchase 3 CDs, 4 cassettes, and 2 videotapes if there are 8 CD titles, 5 cassette titles, and 5 videotape titles from which to choose? So the idea here is we have to take these numbers and we have to make 3 different events out of them. Okay, so the 3 different events are going to be purchasing a CD, purchasing a cassette, and purchasing a videotape. You can tell this book is pretty old, or at least this problem is pretty old, because cassettes. I don't even know if you guys have seen one of those before, but anyway, well, doesn't really matter. So let's take a look. So there's going to be 3 events here. Event 1, Event 2, and Event 3. We'll just kind of see like what order they write. So they write 3 CDs. They write the CDs first. So let's say picking a CD is Event 1, or picking CDs is Event 1. Okay, and then picking a cassette will be Event 2, or picking 4 cassettes, I guess, would be Event 2, and then picking 2 videotapes would be Event 3. So we have CD for our first event. We want to pick some cassettes for our second event, and then we want to pick some videotapes. Again, that's kind of dated. The math still works, so whether or not the example is relevant to you now, we can apply it to a different, we could say, something different things that are relevant to you guys. Okay, so let's talk about the CDs first. So going back to the book, we want to purchase 3 CDs, but there's 8. And so what we want is we want to choose 3 CDs from 8. Okay. Then the next piece here is we want to choose 4 cassettes from 5. Okay, so there's that one. And then we want to be able to choose 2 videotapes from 5. Okay, so now we have all the information we need. And each of these events is going to have its own number of ways to happen. And we're going to have to figure out what those are. So this is actually going to become 3 different problems that we're going to do, and then we're going to multiply all the answers. So this kind of uses the fundamental counting principle of saying if there's this many ways for this event to happen, and this many ways for this event to happen, and this many ways for this event to happen, that you multiply them all and you get the amount of ways there are for all 3 to happen. So let's do 8C3. So that's a combination where you're choosing from 8 things and you're choosing 3 at a time. Okay, so 8 factorial over 3 factorial, 5 factorial. So if we expand this, we're going to get 8 times 7 times 6 times 5. And I'm going to stop there. And this is kind of a trick I showed in one of the last videos. You don't have to write 5, 4, 3, 2, 1 all the way out, because here's a 5, 4, 3, 2, 1 right there. So what I do is I write the top number out, like I expand it, until I hit the biggest factorial on the bottom, because I want to cancel as many things as possible. Okay, and then you can do this at once. You can say I'm going to cancel 5, 4, 3, 2, 1 with 5, 4, 3, 2, 1. It saves you some writing. Okay, be careful that you don't cancel out a factorial with something that isn't a factorial, because this isn't a regular 5. This is a 5 times a 4 times a 3 times a 2 times a 1, and I need to make sure I cancel that with a 5 times a 4 times a 3 times a 2 times a 1. Okay. All right, so I have 8 times 7 over 3 times 6, excuse me, over 3 factorial, 3 times 2 times 1. Okay. 3 times 2 times 1 is 6, so this whole 3 times 2 times 1 cancels with this, and I get 8 times 7, which is just 56. So there's 56 ways to choose a CD. All right, now we got to do the cassettes. So we have 5 cassettes to choose from. We're going to choose 4. Okay, so we're using our combination formula. N factorial over R factorial, and then N minus R would be 5 minus 4, which is 1. So notice 4 plus 1 is 5, 3 plus 5 is 8. Okay, so 5 times 4 factorial. Okay, that's nice, over 4 factorial, 1 factorial. Okay, well the 4 factorial, 4 times 3 times 2 times 1, can cancel with this 4 times 3 times 2 times 1. 1 factorial is just 1, so this is just 5. Okay, so the number of ways I can choose a cassette, the number of ways I can choose 4 cassettes is 5. The number of ways I can choose 3 CDs is 56. Okay, now I got one more. I gotta do the videotapes. Okay, so we got the number of ways, the number of videotapes I have to choose from, and then I want to choose 2 of them, or choose 2 at a time, and there's 5 I can choose from. And then 3 factorial is going to be my other thing there. So 5 times 4 times 3 factorial. Again, I'm just going to stop at 3 factorial because there's a 3 factorial there. So this is 3 times 2 times 1, and this is 3 times 2 times 1. And I can just kind of take care of those. 2 factorial is just 2 times 1. It's just 2. So I have 5 times 4 over 2 times 1. So you can either say this is 20 over 2, or you could cancel out this 2 with a 2 in here and say it's 5 times 2. Either way, you're going to get 10. Okay. Okay, so this is the number of ways I can choose or buy 3 CDs if there's 8 choices, the number of ways I can buy 4 cassettes if there's 5 choices, and the number of ways I can buy 2 videotapes if there's 5 choices. Because the order that I pick them in doesn't matter. Okay, so now we're going to do 56 times 5 times 10. All right, so 2,800 ways for that to happen. All right, cool, so that's number 6. Let's take a look at number 7, which is going to be similar, but it's going to talk about probabilities. Okay, so a survey of 30 people showed that 19 people favor a new city regulation and that 11 people oppose it. Find the probability that in a random sample of 8 respondents from the survey, exactly 3 favor the proposed regulation and 5 oppose it. Okay, well, that's a lot going on, okay? The first thing we got to know is probability. Okay, probability is the idea that it's the number of things that we want to happen over the total number of outcomes, okay? So what we're going to do is we're going to randomly sample 8 respondents out of 30, okay? So what we need to find is a couple things. First of all, we need to find out how many ways are there to choose 3 in favor and 5 that oppose from 19 that favor and 11 who oppose. So this is actually going to kind of start out just like the same problem, okay? So we have two events, right? The 2 events are we want to pick 3 people who are in favor, and we want to pick 5 people who are opposed. So we're going to pick some people in favor, and we're going to pick some people that are opposed. Okay, let's see how many we have to choose from. So going back to the problem, we have 3 that favor out of 19. Okay, 3, so 3 out of 19. So we have 19 people to choose from, and we're going to choose 3 of them. Or we want to be able to select 3 at a time from 19. That's all the different ways there are to choose somebody who's in favor. Or to choose 3 people who are in favor, excuse me. Okay, and then the people who are opposed, there's 5 who oppose this regulation, or we want to choose 5 that oppose it out of 11. Okay, so there's 11 people that opposed it. We want to figure out how many ways there are to choose 5 of those people. Okay, so let's figure out each of these separately and then multiply them. All right, so we got 19 with combination 3. So 19 factorial over 3 factorial, and then 19 minus 3 is 16 factorial. So this is going to be 19 times 18 times 17 times 16 factorial. I could write 16, 16, 15, 14, 13 all the way down the line, but we don't really need to do that. Because this is 16 times 15 times 14 times 13 all the way down the line, and so is this. So I'm just going to cancel these guys out. Okay, so I have 19 times 18 times 17. Over 3 times 2 times 1, because I still have that 3 factorial. And this is 6. And 6 goes into 6 once, and 6 goes into 18 3 times. So I really have 19 times 3 times 17. That's the number of ways there are to choose 3 people from a group of 19 people who are in favor of this thing. So 19 times 3 times 17. Okay, it's a pretty big number. That's 969. Okay, now we got to do the other one. How many ways are there to choose 5 people from a group of 11 that oppose this regulation? Okay, let's go over here so we have some space. So we have 11 people who oppose this in the survey, we want to figure out how many ways there are to choose 5 of them. So we're going to have 5 factorial over 6 factorial. So this is the number we want to choose at a time. 11 minus 5 is 6. So we have 11 times 10 times 9 times 8 times 7 times 6 factorial all over 5 factorial, 6 factorial. Okay, so the 6 factorials cancel, and then I have 11 times 10 times 9 times 8 times 7 over 5 times 4 times 3 times 2 times 1. Okay, let's see if we can cancel some stuff out here. So we don't have a 6 to cancel, we don't have a 12 to cancel. We might have to just do this a piece at a time. So let's cancel a 4 here with a 4 that's in the 8. So there's a 2 there. Okay. And then we're going to cancel a 3 here that's in the 9 here, so there's going to be a 3 left over there. Let me refocus here. And then there's going to be a 5 and a 2 make a 10, and then the 1 doesn't matter. So what looks like what we're left with is 11 times a 3 times a 2 times a 7. Okay, and that's going to give us 462. Zoom out again. Alright, so let's figure out what that is. 969 times 462. Okay, that's 4, 4, 7, 6, 7, 8. So there's 447,678 ways to choose 3 people in favor of this regulation out of 19. And 5 people who are opposed to this regulation out of 11. Okay, but we have to remember that this was a probability question to begin with. So the event that I wanted, the event that I'm looking for, is the probability that I pick 3 of these guys and 5 of these guys. And this is how many ways there are for me to do that. Okay, but what I have to take into account is the total number of ways that I can take this survey. So let's look back at the problem and say, a survey of 30 people, right? Well, there's 30 people total, and what you're going to do is you're going to pick 8 of them. Okay, so I got to figure out how many ways there are to pick 8 from 30, because I may not get 3 in favor and 5 that oppose. I could get like 4 and 4, or I could get 7 and 1, right? So I got to take into account all the possibilities. So in my probability, the number of outcomes where A occurs, that's the top part. That's what we got right now. We just got the top number. Okay, this is the number of ways to get what we want, the number of ways to choose 3 people who are in favor from 19 and 5 who oppose from the 11. Okay, this is the number of ways for that event to happen. Okay, now we have to figure out the total number of ways that this could go. And so for that, that's going to be the bottom number. What we need is 30 people, and we're going to choose 8 of them. Okay, because again, I might not get 3 and 5. I might get a different arrangement or a different combination there. Okay, so this is going to be a big one. 30 factorial over 8 factorial, 22 factorial. Okay. Now we could do this by hand. We could go out real far and do it. I'm going to help you out with this one, and we're going to do this with our calculator. Okay. So let's take a look. We're going to do 30 factorial, and then we're going to divide that by 8 factorial times 22 factorial. Okay, so that's a pretty big number. This is all the ways that all the different combinations we can get when we're surveying 8 people from 15. or 8 people from 30, excuse me. So that is, once again, 5852925. Okay, so that's like 5,852,925. So what we need to do is we need to take the number of ways that I can get 3 in favor and 5 opposed, and I need to divide that by all the possibilities of surveying 8 people, or picking 8 people from a survey of 30. So I need to find out what this fraction is as a decimal. So let's do that. So all right, it's 447,000. Put that down for you so you can see it. 678 divided by 5,852,925. Double check my numbers real quick. 5,852,925. Okay, looks good. And that's the probability. So that's about like close to 8%, right? So the probability here is 0.076 or 7.6%. Okay, that's the final answer. So, whew, that's a long one, right? Pretty long problem. But the idea is it's a probability, and in a probability we got to figure out the number of ways to get the event that we're looking for divided by the total number of ways that this thing could go down. Okay, so the specific outcome that I'm looking for in number 7, the specific outcome is I want to choose 3 that favor and 5 that oppose when I pick 8 respondents. So again, I got to figure out, well, how many ways are there to pick 3 in favor from 19 that are in favor? And how many ways are there to choose 5 that oppose from 11 who oppose? That's the total number of ways to get the outcome that I want, and then divide that by how many ways there are to choose 8 surveys people from the 30. Okay, so that should that's going to help you with 6 and 7. Now there's a couple more probability questions we're going to get to later on, and when we get there, we'll do another few to get you started, because the probability ones are a little bit tricky. That's it for now. I'm going to make one more video for you guys.